Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss pressure of a longitudinal wave. Let's begin. As we studied about plane progressive wave, it is categorized into two, that is transverse wave and longitudinal wave. That the graphical representation of transverse wave. That is the graphical representation of longitudinal wave. Why it is necessary to find out the pressure of a longitudinal wave? In case of transverse wave, we see there will be no such variation of pressure, means the pressure is constant. But in case of longitudinal wave, there will be the variation of pressure, as one is compression, that region is the region for compression, and that region is known as the rarefaction. Therefore, variation of pressure introduce. That's why you have to calculate what be the pressure in case of a longitudinal wave. In case of transverse wave, that is crest, that is trough, and the particles are vibrating in SSM throughout that of medium. There will be no such variation of pressure. Here only variation of pressure takes place, as a number of particles vibrating in that of region is high as comparison to the number of particles vibrating in that region. So there will be a variation in pressure. Let me calculate what be the pressure in case of longitudinal waves. As it is under the category of plane progressive wave, therefore we take the equation of a plane progressive wave, and from that equation we derive how that equation is similar to that of pressure equation. Y is equal to A sin omega t minus kx, the equation of a plane progressive wave. Let me consider that longitudinal wave is a plane progressive wave. Here the terms like y is the displacement along the direction of propagation, that is along x axis, or you can say positive x axis, at any instant. And here the pressure varies from particle to particle. A, the amplitude of wave K, that is the propagation constant, or we can say the wave number, propagation constant or wave number. Omega, that is the angular frequency of the wave, angular frequency of the wave. Here we consider, let us consider the longitudinal wave as a plane progressive wave. Plane progressive wave. Therefore, the wave equation is written like this, that longitudinal wave is a plane progressive wave. That's why the wave equation is written like this. Here also we prefer, let P be the pressure, let P is the instantaneous change in pressure at a point x. Therefore, the pressure P is equal to minus K dy by dx, where K is equal to the Bock modulus of the medium. Here the medium is air. So the Bock modulus, we define the Bock modulus is nothing, that is stress per volume strain. And it is negative, so negative stress, that is P, volume strain, change in volume by original volume, and that can be solved, change in volume to original volume, and the volume is area into length. By solving that volume strain, it is written as dy by dx. So P pressure is equal to minus K dy by dx. Okay. Now we differentiate that equation 1 with respect to x. Differentiating equation 1 with respect to x, we get dy by dx is equal to d by dx a sin omega t minus kx, or dy by dx is equal to a d by dx of sin omega t minus kx, or dy by dx is equal to minus k a cos omega t minus kx. Now we can put the value of dy by dx as p is equal to minus k dy by dx. So in place of dy by dx we can substitute these values. Let that be the equation number 2. Putting the value of dy by dx in that equation 2, therefore equation 2 becomes pressure P is equal to minus K, that is capital K, which is the bulk modulus. Here small k is the propagation constant. So minus K, in place of dy by dx we substitute, that is minus small k a cos omega t minus kx or P is equal to minus plus k a small k cos omega t minus kx. Here the velocity of a longitudinal wave, velocity of longitudinal wave v depends upon two things. One is bulk modulus, another one is the density of medium rho. The relation velocity of longitudinal wave v is equal to under root of bulk modulus to that of density of medium, where rho is the density of medium. From that of expression, the bulk modulus can be equated squaring v square is equal to k by rho, or k is equal to v square rho. In place of bulk modulus we substitute v square rho. Therefore pressure P is equal to v square rho a small k propagation constant cos omega t minus kx. Look here, that term v square rho a k is known as P maximum. The term is known as P maximum cos omega t minus kx. That entire term is known as P naught. P naught. Here v square rho a k is equal to P naught. Look here, that value will be maximum when that cos of this will be maximum, when cos omega t minus kx is equal to 1, means the value of cos is maximum, then that term p is equal to p max, which is known as p naught, is equal to that value v square rho ak, as we define, that is p is equal to p naught cos omega t minus kx. Here we get y is equal to a sin omega t minus kx, and we have in terms of pressure p is equal to p naught cos omega t minus kx, that is known as, that is the pressure equation, of longitudinal wave. Therefore, what exactly that equation referred? Hence, a longitudinal wave which is known as also a sound wave under the category of longitudinal wave may be considered as either displacement wave, or we can say that is the plane progressive wave, or pressure wave. So that longitudinal wave is either displacement wave or pressure wave. If we plot the graph between that displacement wave and pressure wave, look here, if we plot a graph, that axis with the displacement y looking like this, that be the this is x axis, let A, B, C, here D, here E, that be the displacement y, and amplitude, that be the amplitude A of that wave that travel along x direction. In case of pressure wave, the phase is just 90 degree out, so that from this here A, B, C, D, E, that along x axis, that is the pressure and the maximum pressure P naught. Look here, in that of case A to B, that for pressure wave, that region is known as the compressions, and that from B to D, which is the negative, here the dy by dx is negative, so that region is the rarefaction. From D to E, dy by dx or that pressure variation is positive, so that region for that of pressure wave is compression one. So with the help of this video lecture, we understand pressure of a longitudinal wave, which is further named as longitudinal wave as a pressure wave. Longitudinal wave as a pressure wave. So we consider a plane progressive wave which is under the category of longitudinal wave is under that category. So taking that longitudinal wave, what be the importance of calculation of pressure in case of longitudinal wave? Therefore we calculate the pressure, that will be the pressure equation known as displacement wave or pressure wave, a comparison between displacement wave and pressure wave. So with this useful and informative notes, let me wind up this session. Thank you.